All right, guys, this time we're going to talk about how transitive logic exposes a major flaw in the scientific method. Let's get into it. Here's your nice title page. Transitive logic exposes major flaw with the scientific method. What is transitive logic, though? It's really quite simple. If A equals B and B equals C, then what? What's the only then you can possibly get from these ingredients? Then A equals C. So if A equals B and B equals C, then A equals C. It's a pretty obvious statement, but you can write it down to make it really obvious. With this simplest of logic, we can demonstrate a fundamental flaw with a modern scientific method. So first, let's have a look at the foundation of climate physics. So this is our B equals C. This is going to be our B equals C. So B equals C, climate science physics. So this is what I mean by that. You see all these diagrams here, all these diagrams, and then here's a bunch of just references to locations where you can find references to these diagrams, word descriptions of these diagrams, or statements that are derivatives of these diagrams. But basically, these physics diagrams, these modern physics diagrams, modern science diagrams are found everywhere. Harvard University, University of Washington, University of Chicago. I was taught this same diagram at my own university during my own undergraduate degree in planetary astrophysics. And so yeah, this is ubiquitous climate physics. This is everywhere. If you do a Google search, it's not just these places. Basically, if you do, this is just a sample. If you do a Google search for basis of climate physics, or you're just looking at climate physics, climate science physics, and you want to work your way back to figuring out what the basis of climate science physics is, you find these diagrams and references to these diagrams, or word descriptions of these diagrams, or mathematical examples of these diagrams, whether the diagrams are showed or not. So this is our B equals C. This is climate science physics. It's modern physics. It's taught in modern universities everywhere, all around the world. So to repeat that, this is our modern climate physics, our B equals C. B is all these diagrams and the math that goes along with them, and the descriptions of what's happening in them, which goes along with them. That's our B, and what it equals is our C, our climate science physics. This is modern physics, okay? Now, I'm changing subjects here totally, okay? We're just gonna have a little fun here. We're gonna pretend to be trolls. We're just going somewhere totally out to lunch here for a minute, okay? Just keep what we just talked about in the back of your mind. We'll come back to it, you remember it. We're just gonna have a little fun now, okay? Flat Earth trolling. And how are we gonna do some flat Earth trolling? We're gonna do some flat Earth trolling with flat Earth physics. It's gonna be really fun. We're seriously gonna super hard troll some people with this. It's gonna be so good, okay? Just watch. Okay, so you might see this thing. It's a disc, but to prove that it's actually a flat disc, I'm just going to rotate it up for you here. So you see that thing rotating in and out of the page. So see, we turn that disc on its side, and so that's a flat disc. I just want to confirm with you that that's a flat disc. That disc was the Earth. That's our flat Earth. When you look at it from the top down, you see a disc, but when you look at it from edge on, then you see it flat. So I just wanted to demonstrate that to you, that we're making an Earth that's a flat disc, because we're flat Earth trolls and we think doing this is funny, okay? So there's our planet Earth. We're just looking at it edge on now. So I'm just drawing it as a flat line there, which is our flat plane, which is our disc that we're looking at on the side. And you can tell that, obviously whoever created the word planet is secretly telling us something, right? Because the word plane is within planet. So somebody's hiding the truth from us, that planets are actually planes, aren't they? Because plane is in the word planet. Real tricky, right? That's some grade A trolling right there. That's awesome trolling. Ha ha ha. I'm such a funny troll. But let's make we really want to super hard troll some people with flat Earth theory, right? I want to go on the internet and I'm going to waste my life and be a complete degenerate spreading flat earth theory online because I'm a disgusting human being that should be. Never mind. Anyway, that's what we're going to do. So here's our planet Earth. But we got to make this look realistic. We want people to believe it, right? We want people to believe in flat Earth theory. We're going to make this flat Earth troll so good, people are going to believe it. Okay, it's going to be great. So let's make this flat Earth a bit more realistic. What can we do? Air. Everyone knows that the Earth has air, right? I mean, we're in air all the time. So like, let's just add another layer here that's air. So air is on top of the planet Earth, right? Makes sense. This diagram is getting pretty realistic now, right? Like we're working our way up to getting people to believe this flat Earth theory. Ha ha ha! We're such funny trolls. But let's make this realistic now. Let's see. What can we do? What else? Air. There's sun. Let's add sun. Yeah, there's sun. Let's add the sun. There's our Mr. Sun, Mr. Happy Sun. So now what we want to do, we want to do add some physics to this. We're just going to create some math and physics to go with this flat Earth troll that we're doing, okay? Because we want to super hard troll some people because it's so funny, right? So if we can create some physics, what could we do? Let's see. Well, let's take the sunlight. We know that the sun is making light that comes to the Earth. Well, we have a flat Earth though, right? So we got to make that sunlight fall over the entire surface area of the Earth at once, right? So I can write an equation for that. So we have this F sun here. So F sun, that just means the energy from the sun, flux from the sun, or heat from, not really heat actually, it's just flux, energy from the sun, okay? So we have to multiply it by the absorptivity of the Earth. Okay, that's fine because the Earth reflects some light, but then we got to divide the sunlight power by a factor of 4. We got to do that because we're taking the interceptive cross section of the Earth, which is secretly spherical, but shh, and we're going to spread that over the entire surface of the area of the Earth at once. And that the entire surface area of the Earth at once is 4 times that intercept cross section that the Earth actually gathers sunlight in. So that's why we divide by 4. So now we've got some great convincing physics here. We're taking the energy of the sun and we're spreading it over the entire surface of the flat Earth at once. This is super hard trolling because people are going to see this equation. Who's going to be able to debunk that? I mean, most people have a high school level education in math, maybe not even physics. No one's going to even try to debunk this. They're not even going to try. But, you know, there are still quite a few people out there with some physics and math education. So we got to make this diagram more convincing. This flat Earth troll diagram more convincing. So what else can we add? Let's see. Let's just work this out a little bit. So with this flat Earth physics that we've forced to create, that we've forced to satisfy flat Earth theory, it comes out that sunlight is only minus 18 degrees Celsius. Well, people know that sunlight is warmer than this. People know that sunlight is warmer than minus 18 degrees Celsius. I mean, it's summertime now. I mean, unless you live in Canada like me, minus 18 is like, you know, that's normal. I'll, you know, go outside on a t-shirt when it's minus 18 degrees Celsius. But summertime now, we know that something weird is going on. So you're not going to be able to sell that the Earth is minus 18 degrees Celsius for this flat Earth physics that we've created to force this physics to work. So what can we do here? I know what we'll do. We have to create some mechanism to make the Earth warmer. So let's just make the air emit some heat. Let's make the air add heat, add temperature to the ground. Let's make the temperature of the air add with the temperature of sunlight so that we get hotter ground. Let's do that. I mean, that's pretty much the only opportunity we have, but here we're creating some flat Earth physics. We're creating some physics in order to satisfy flat Earth theory, okay? So now heat from sun plus heat from the air can be made so that the heat from the air makes up for the inadequate heat from the sun. That's great. This is super good physics, super good stuff. So now if we work this out, I'll just work this out on the side on a scrap piece of paper. kind of worked out that you need something like the air has to provide basically somewhere around twice the heat as the sun in order to make this flat earth theory work. Okay, so the air provides twice the heat to the ground than the sun does. Haha, we're such funny trolls. We're gonna troll some people so hard with this. I mean, we're just gonna troll hard. Like, man, I am so satisfied in life that I get to troll and spend my life on the internet trolling. That's what the universe was created for. The universe was created so that people could create energy from nuclear power plants, so that I could be on the internet, so that I could troll. This is awesome trolling. So just by way of confirmation here, let's look at this diagram that someone else created, someone else named Akil, and the other guy is named Trenberth. And you see these numbers here, this 342, that's actually for flat earth theory, because that's actually the value of sunlight divided by 4, the power of the sunlight divided by 4. That's what that is. So even though there's a little curve drawn here for the earth, the numbers, and that's what's important here, because the numbers are what's driving the physics. The numbers are actually for our flat earth theory that we actually created previously, in the previous slide. So this number is actually the flat earth value. the energy from the sun divided by 4. And so we see that down here, there's 168 absorbed by the surface, and that's just units of energy or heat or whatever, really just energy. And over here, we have 324 coming from the atmosphere. So that actually worked out really good. That is about a factor of 2. You get twice the heat of the sun. People actually figured this out. You get twice the heat of the sun coming from the air. And that's why it's not minus 18 degrees Celsius. Okay, guys. All right. Playtime is over. What did we just do? What did we actually just do? We did, let's go back to our statement. If A equals B, this is real logic now, right? Transitive logic. If A equals B and B equals C, then A equals C. So think about this. Earlier we had B equals C. The diagrams and the math of the climate science greenhouse effect is modern climate physics. And we see that this is ubiquitous. It's everywhere. Everywhere you go, you have this. So B equals C. The diagrams and math of the climate science greenhouse effect is modern climate physics. Uh-oh, but what did we just do? We just did A equals B. We just did flat earth trolling, and in flat earth trolling, we created the diagrams and math of modern climate physics. Well, did we troll, or did we just do some super good physics? Maybe I wasn't trolling at all. Maybe I was doing some super good modern physics for us all to believe in. So earlier we had B equals C. The diagrams and math of the climate science greenhouse effect is modern climate physics. What we just did for fun, A equals B. From flat earth trolling, we created the diagrams and math of modern climate physics. Therefore, come on guys, what's the therefore? Therefore, A equals C. Flat earth is modern physics. No joke, no troll. We were just having a bit of fun. That's the truth of it. A equals C. Flat earth is modern physics. Get around that. I'd like to see how you can get around that. How are you going to ignore that? A equals C. Flat earth is modern physics. From flat earth trolling, we created the diagrams and mathematics of modern climate physics. And B equals C. Those diagrams are modern climate physics. A equals C. Modern physics accepts and is flat earth. Flat earth is modern physics. Flat earth is modern physics. A equals B equals C. What does this expose? What does it indicate? It doesn't indicate anything other than that there is a major error in the modern scientific method. This is quite serious, actually. If you consider the scale of the error, consider the scale of this error. Not only just that on the one hand, that this flat earth modern climate physics is presented as the most important science that physicists and scientists and geologists and geophysicists have ever produced for practical governance and societal consumption. It is presented as the most important issue of our time, by far and away. It has people freaking out all over the world, particularly in the West, though. Seems to really be a problem here in the West, most of all. But think of the scale of this error in other terms. This is an error that goes at least back 2,500 years, probably further. But if you know your Greek history, there was this astronomer, philosopher, Aristarchus of Samos. And he was one of the first to come up with a really accurate value for the circumference of the Earth by doing some measurements with sunlight. Basically, he proved that the Earth was round that long ago, and probably people knew that through other methods or maybe through similar methods that he used well before that. So this is several thousand years. For several thousand years, people interested in natural philosophy and doing real science and physics and whatnot have figured this out, that the Earth is round, not flat, and that it's important to know. And it's important to take account, and it's important to have a round Earth instead of flat Earth in your physics models, right? So this is quite the scale of an error. It's pretty much as big, and I can't think of anything bigger. I can't think of anything more ludicrous. For if modern science, if you were to ask a person, what is the biggest mistake that modern physics could make? And I can't think of anything other than saying flat Earth theory. If it included flat Earth theory or something like that, or it reverted or resorted to flat Earth theory. What bigger scale of error can science, geophysics, physics, astrophysics make? What planetary science, planetary physics? There's no bigger scale than this. This is pretty much ultimate. It is ultimate in scale. So given the scale of this error, what does it indicate? It indicates that there is a systemic error occurring somewhere within and between introductory pedagogy, that means introductory science in high school, maybe grade school. So there's an error that occurs somewhere starting there and ending somewhere with professional PhD, peer review, and journal publication in physics and astrophysics and all these other places where you find these diagrams. Those scales match. Given the scale of this error, it indicates that there's a systemic flaw that is occurring in the scientific method and its pedagogy from the beginning right to the end of how science is conducted. It's a big deal. It's a big deal. Let's discuss this a little bit more. Some people, when they are confronted with this, they start to kind of lose their mind, lose cohesion a little bit. And it's not surprising. It's well-founded. People start saying, well, if science has made this error, then maybe any number of conspiracy theories are true or something like that. Maybe the Earth really is flat, they might say. And all I have to say is just don't lose your reason. Like, don't be like, oh, the moon landings never happened and this and that, or whatever. Like, you still have to base your reasoning on logic and on evidence and things like that, right? So don't lose your reason. Yes, there is a big error somewhere. Yes, you may have to reevaluate things that you think, confidences that you have. You may feel that our knowledge isn't as sure as you thought it was. And those are all good things to actually think and feel, because there's something has to change, right? Something needs to be fixed. Something needs to be acknowledged. We need to figure this out, right? The good news is that we have the solution. We know why and how, not everyone. We know why and how modern science could allow this error. We know who we can trust to fix the problems. Now, the thing is, it is self-evident that you can't trust most scientists to fix this problem, unfortunately, and simply because they're the ones who let it happen. Simply because it happened under their watch. It's self-evident. If you want someone to fix this problem, who are you going to get to fix? The people who made the problem and who won't acknowledge it, and who deny that it's a problem, and who plead that maybe flat Earth theory is okay to have for actual modern physics. You're not going to be able to get these people. Maybe they would come around. Maybe they could. I hope they could. But evidence in my life has shown that they won't. They don't want to acknowledge it. They don't want to talk about it. They don't think that it's important. They don't think that distinguishing between flat earth theory and actual spherical earth reality is important. They don't think making the distinction is important. They don't think it has a difference in physics. In my last video, we showed that it does make a difference in physics, because with the flat earth theory physics, the climate cannot create the climate. Climate science, climate physics cannot create the climate in flat earth theory physics, which is modern physics for the climate, because the sun doesn't have enough power to, because they do this thing where they force sunlight to fit a flat earth, and that reduces the power of sunlight. And in that last video, I showed a more realistic conceptual diagram and showed that the sun has all the power required to create the climate. And so, yeah, that does make a big difference. It makes a big difference having flat earth physics versus real earth spherical physics. Flat earth physics, the sun can't create the climate. Spherical earth physics, the sun can create the climate. You understand that's a binary difference? You understand that's important? Why don't you want to think that's important and acknowledge it? Ask your local physicist why, because I can't get an answer from them. Anyway, we know who we can trust to fix the problems. It's actually a psychological problem. It's really just psychology. You need INTPs on the Myers-Briggs spectrum to be able to detect problems like this. INTPs are good detectors at problems, detectors of problems. Now, the good solvers of problems are actually INTJs. INTJs are very good at solving problems once they see them. INTPs can show them that there's a problem. INTJs can detect them too, but INTPs really get deeply into a problem, can pull it apart at all of its different levels. INTJs can identify the problem and quickly come up with a solution. INTPs aren't as good at solutions. INTJs are very good at solutions. So INTJs directing mainstream scientists can be used to correct the problems. You can't trust mainstream scientists to correct them because self-evidently they don't have the psychological tools. The reason is psychological again. They're, instead of the N in the Myers-Briggs, they're typically S's. That means they're sensing rather than intuitive. They're perceptualists rather than conceptualists. Now, to a perceptualist, a person who is empirical based, who's very much of the sensing function, right? You're very empirical. I guess the idea of drawing a flat line and presenting it as the Earth with some physics attached to it, some numbers, I guess it becomes reasonable to them, because when you look out on the world, sure, you see a flat horizon. So I guess for them, it just doesn't get detected as a problem because they're strong, because they're perceptualists, right? They're sensors, they're empiricists. So I guess they just don't register that it could be a problem as readily as an intuitive does, because an intuitive is generally a conceptualist, right? And a conceptualist is looking for the concepts to match, not the percepts to match, not your senses to match, but your thought forms to match, your ideals to match. So obviously the ideal is you might see a flat horizon, but that's not what actually exists. What actually exists is a spherical Earth, and it's important and it makes a difference. So that would be one way of going about structuring things if you wanted to get people on board to look for problems and solve problems. It's kind of that sort of a psychological problem. INTPs and INTJs would be the best people to use. Scientists typically being ISTs and then either Ps or Js. That S function in their personality really seems to hammer their ability to, conceptualize problems, or, you know what I mean? Anyway, so we know how to reorient or modify the scientific method in order to prevent this error and others like it. We know how to do it now. We know what the error was. We know how to reorient science. If you want to know too, you should read the pseudonym authors and philosophers Mike Hockney and Dr. Thomas Stark. Just look them up. If you read all of their books, you will be the most knowledgeable philosophers and scientists on the face of the planet today. There's not many people who have accomplished this feat of reading all that material. It's several million words. It's quite a few dozen books. Not many people can get through it all. If you get through it all, you can only get through it all if you're an INTP or INTJ. Anyone else will simply not be able to handle it, probably. But if you read them all, you will know more philosophy, more physics, more science, more religion, more psychology, more everything than pretty much anyone else in existence. So you have to participate in this. You don't have to read those books if you don't want to, but you at least have to participate in deciding whether you think flat earth physics is real or it's not. I mean, these are pretty high stakes here. Don't you think it's pretty high stakes? I mean, if science, physics, modern physics can make a mistake like this, what other mistakes is it making? What other mistakes has it made? You know, we're being asked essentially to pay taxes to fight weather, to fight air, to fight processes that are galactic in scale with cosmic ray flux, which reaches the inner solar system, dependent upon the solar magnetic activity. I mean, we're paying taxes to fight things which are far beyond our influence. It's ludicrous, right? It's ludicrous. And it's not just that I don't want to pay taxes. It's not like that's what motivates me. I'm not motivated because I don't want to pay taxes. I'm motivated because I'm interested in truth, because I'm a scientist, because I'm a philosopher, and I want truth, and I value truth. I could care less about taxes. I pay enough taxes. If you add a few percent, am I really going to notice? Maybe, maybe not. I really don't care. That's not what motivates me. What motivates me is scientific truth. And I don't know why the mainstream of scientists, well, I do know why. It's because of their psychological personality type. But anyway, I wish that they would pay more attention to it and take it more seriously. I grew up reading Carl Sagan in my late teens and early 20s. He was a hero of mine, a hero scientist who I wanted to emulate. And I think it was in his books that he wrote about the value of error, the value of finding error and detecting error, and the value of admitting mistakes and when you're wrong and when things have gone wrong. I really took that to heart. I thought that was important. And the reason that he explained why it was important is because the detection of an error is as valuable as detecting the truth. Like if you detect an error, then you've corrected false thinking and you can now go try to find the truth again. I don't know. I'm interested in truth. I like those ideals of the ancient Greek philosophers of, you know, the ideas of finding truth. I mean, we're here in this weird planet, in these weird bodies. Don't you want to figure out what it's all about? We have to figure out correct physics. You have to value truth. I just value truth. Don't you value truth? Anyway, so I think that's it. I think that covers it. Hopefully I didn't ramble off too much on anything else. Let's see, let's expand this. So, yeah, I guess that's it. Might as well cut it off. Keep it short. All right. Take care, guys. Bye-bye.